Okay, let's unpack this. Imagine crafting components for, well, everything from skyscraper structures to really complex aerospace parts. Precision bending isn't just some art form, it's a critical engineering challenge. Today, we're taking a deep dive into the world of industrial bending machines, specifically looking at how Ercolina's advanced technology tackles some of the industry's most persistent, well, headaches.
Yeah.
Our mission here, to uncover the game-changing innovations that, truly make them stand out.
Yeah, and what's fascinating here is how Ercolina directly confronts these long-standing engineering challenges you find in older traditional swing arm systems. We'll explore how their patented innovations in core components lead to improved precision, efficiency, and safety, which is crucial for demanding industrial use. And they handle a complete line of tube, pipe, and profile bending needs.
Right. So, to really appreciate the advanced ends, let's first maybe get into what makes traditional swing arm benders a bit problematic. What we've gathered describes how their clamp dies, the parts that hold the material, are mounted on a carrier that actually swings with the main bending die. Imagine like a seesaw, this swinging motion creates this massive off-center force or offset load,
Mm.
and that apparently causes the bending die to tilt, pulling it out of alignment with the other parts. That sounds like a recipe for wildly inconsistent results.
Exactly. And this tilting issue, especially with older machines, well, it means the clamp surface can pull away from the workpiece, reducing its grip. So to fight this, traditional designs often need these overhead tie bars. Think of them like cross beams trying to hold everything steady, plus center posts and really complex hold-down patterns.
Okay. Which sounds like it makes tool changes a nightmare.
It does, and it can generate excessive, often hard-to-measure clamping force, too.
And I guess as these traditional machines get larger, the swing arm itself has to become like disproportionately massive just to handle those forces.
Absolutely. Yeah, it often means you need more complex drop-away mechanisms or other design compromises that ultimately just increase maintenance and decrease reliability.
Okay.
And this is truly where Ercolina starts to differentiate itself. Their design positions the bending axis directly beneath the pressure die. This completely eliminates the need for those restrictive tie bars and prevents that material slippage we talked about.
Ah, I see.
Their Gigabender series, for instance, uses these large spindle and bearing diameters for maximum rigidity. They're engineered to, state-of-the-art machine tool standards.
So we're seeing a pattern here then. Ercolina isn't just making small tweaks, they're fundamentally redesigning foundational elements for both safety and precision. What's one of their like cornerstone innovations that really tackles these issues head on?
Well, their patented KST clamshell clamping system is a pretty radical departure. It mounts directly over the machine's central bending axis, cutting out those outdated swing arm and tie bar systems entirely.
Okay, no swing arm, no tie bars.
Right. And with two double-acting cylinders creating direct proportional pressure, you get basically no clamp pressure-induced bend die tilt, even with really heavy workpieces.
Yeah.
The clamping forces are self-contained, meaning there's no stress on other machine parts.
That makes sense.
Plus, tooling installation is simpler, and changing tools is much faster because you don't need those vertical or horizontal adjustments. And importantly, it eliminates dangerous pinch points found in older designs, making it significantly safer for the operator.
Safety and precision combined, yeah, that's definitely key for industrial use. What else stands out in their core design philosophy?
Well, their C-axis design, which is essentially the machine's main bending mechanism. It uses a single two-speed hydraulic cylinder for both bend and return functions. Makes it simple to regulate and, maybe surprisingly, reduces the machine's overall footprint.
Oh, interesting. Smaller footprint, too.
Yeah. The bend head itself moves transversely for radius adjustment, which makes tool setup much easier. And it's made entirely of spheroidal cast iron. Now, that material offers incredible stability and absorbs vibration, which means smoother, more consistent bends.
Okay.
But what's truly innovative, I think, is how the patented tunnel structure frame works in compression. Unlike traditional frames that effectively bend or flex under force, think of it like trying to compress a solid block versus trying to bend, say, a piece of wood.
Right, right. One is much more stable.
Exactly. This compression design boosts stability more than 50 times, apparently, with less weight. And it ensures the mandrel position, that's the internal support for the piper, remains totally steadfast, even under extreme force.
Wow. 50 times more stability with less weight. That's like swapping out some bulky old workbench for a super stable, lightweight platform, kind of an engineering magic trick. And they've also got a powered indexing carriage. That sounds incredibly helpful.
It really is. Less expensive benders often offer only manual carriages, But Ercolina's powered system advances and rotates the workpiece with precision between bends. This is especially beneficial for heavy pieces. It allows for safe, accurate, one-man positioning, and that dramatically reduces labor costs.
Yeah, I can see that being a huge plus.
So bringing it all together, Ercolina's approach isn't just some incremental upgrade. It feels more like a fundamental re-engineering. By tackling those inherent flaws like tilting and instability with innovations like their unique bending axis, the KST clamping, and that compression frame, they've really set a new standard for consistency and reliability in heavy-duty industrial bending.
So, what does this all mean for you, listening? When you're dealing with the demanding task of bending and forming various profiles like tube, pipe, or square material, understanding these technological leaps from companies like Ercolina means recognizing where true engineering innovation can significantly enhance product quality and operational efficiency, which I suppose raises an interesting question. In what other areas of industrial fabrication might a fresh look at core design principles unlock similar kinds of breakthroughs?